So we have actually completed the first module. First module, which consisted of elementary concepts of DC electric circuits, and in which we discussed a little bit about Ohm's law, Gauss law, star delta conversion, about what is resistance, what is current, what is the flux. I mean, sorry, the EMF, current, voltage, etc. Terminologies, and also what happens when resistances are connected in series, when they are connected in parallel, and all those equivalent resistances and so on. Second part of the first module consists of analysis of DC electric circuits. Only DC, only resistance comes in, where we dealt with mesh current analysis as well as node voltage analysis. And in mesh current analysis, in the just previous class, we discussed about super mesh, and in node voltage analysis, we discussed about super node. I have given you written notes, class video, written notes, as well as PDF on this part. So many problems have been done. You can work on it. And also assignments have been given, plus second assignment based on question papers have also been given. Okay, you have enough time to do that. Once you have, I request all of you to really do those questions by yourself, so that you will feel extremely confident for your examinations and extremely confident for your interviews as well. Moreover, you have this comprehensive examinations also, Viva, where also you will find that these will come in handy for you. Okay. So now today we are going on to module 2, which essentially consists of the elementary concepts of magnetic circuits, electromagnetic induction, and AC fundamentals. Before which, I want to make sure that you have really understood the concepts which we have discussed in module 1. If you have any doubts, or let it be a silly doubt, no problem. Actually, we have certain limitations because of this online class. If had it been offline, I would have dedicated one single period for all your doubt clarification and all those things, which is indeed very difficult. None of you know me personally, nor do I. I have no problem in conveying anything, but you really have some kind of a hesitation on your part, which is what I understood. So if at all you can ask, and if at all you have any doubts, you may ask me now. I'll just pause a little before I go for the next module. Go to the next module. Let it be a silly doubt. No doubt, as far as I am concerned, no doubt is a silly doubt. Maybe a silly doubt may lead to some problems for me also, which I would like to, from a researcher point of view also, I like to investigate on a silly doubt and come up with good answers. So don't worry. All of you are much knowledgeable, I know, but whatever little contribution that I can do from my own experience, that is all that I will be doing in these classes, because I am very sure that you have learned all these things in your +2 classes. But maybe the approach may be a little bit different in when you come to engineering. That's all. From the examination point of view and from the marks gaining point of view, there is nothing special about this class. But maybe it will be helpful for you in future. So let me pause. Well, now it's 11:07. I'll pause for 1 minute before you can. If there are more questions, we'll go on discussing about it, about module 1. Okay. Yeah. I'm waiting. Crystal clear? By the way, in the department, there are 2 Bindu teachers. Okay, I am Bindu GR. You can remember me with primary colors, green, red, blue, GRB. The other teacher is Bindu VR. Okay, I am GR. So there have been a lot of confusions earlier, and this time also there are a lot of confusions regarding who took that class, who took this class, and all those things. Okay. So remember me as Bindu GR. Green, red, blue. Okay. If there are no further doubts in the first module, we'll go straight away to the second module. Now, second module, as I read, is consisting of magnetic circuits and electromagnetism and AC circuits. Now, when it comes to magnetic circuit, all of you should know that the Hindi cinema, in Hindi movies, we'll always have these judwa bhais, or earlier days we had this family which gets separated in during some maybe a train accident or something, and then the brothers come like Amar Akbar Antony or Johnny Janardhan and something like that. So, or twin brothers who then are brought up by one by a rich man, and the other brother will be brought up by a very poor, in a poor family, or by a kollakaran, or like, dacoit. And then they finally meet, and then they find that there are so many similarities within them, and there are so many differences also. Similarly, when we speak about electricity and when we speak about magnetism, they're so much alike. At the same time, they are so much different also. But at the same time, they cannot exist on their own. An electron cannot exist without any attraction towards its neutron or the nucleus. And a magnetic circuit can always give rise, a moving magnetic circuit, magnetism can always give rise to electricity. So they are, they are stuck together for life. Just like how a husband and wife is. You cannot say who is better, who is more powerful. No, they are together. If you have your parents together, similarly, you have electricity and magnetism together. You cannot say one is better than the other. Both are there. Okay. So though we are learning some of the basics of magnetic circuits, actually, again, a name which I would like to mention, two names which I would like to mention are that of Maxwell and Oersted. Maxwell framed 4 equations, which you will be learning only in your electromagnetic theory later on, maybe in S3 or S4 or S5. Maxwell's 4 equations which connected electricity or electrical, which were connected with electrical quantities and magnetic quantities, magnetic quantities, like how the brothers come together in the final scene. Such 4 equations were framed by Maxwell, which revolutionized the whole arena or whole field of whole area of electrical engineering. And that is how we came up with so many things that we could, many of the phenomena that were occurring even in nature could be explained by these 4 equations. Maxwell became extremely famous, but there was one person called Oersted who actually made so many equations. Maxwell just, made it concise into 4 equations. Oersted is also remembered for his contributions, but Maxwell is remembered more. He has been projected as, the one person who revolutionized the whole of electrical engineering and magnetism. When I say electrical engineering, magnetism comes together with it. This is not there with any of the other engineering fields. Okay, whenever you are learning electrical engineering, no matter who you are or whether you have likingly or lovingly taken the branch or not, there is magnetism in you. We are all very attractive. All of us. All the boys and girls, all the faculty, all of them are very attractive because we are learning electrical engineering, and over time we are becoming more and more magnetic and attractive for everyone. Okay, so now let's go into the actual magnet. And have you heard of polar lights? Polar lights. If you have not heard of polar lights, Just Google and check. This is a wonderful phenomenon that is occurring in the North Pole of Earth because of magnetism, because of Earth's magnetism. Now, what can you say about Earth's magnetism? Earth has its own magnetism. Why does Earth have magnetism? Because in the deepest or in very, very deep to the Earth's crust, there are lots of ferrite and all those iron and all those things. So much so that because it rotates, Earth has magnetism. Earth's magnetism, can anyone say what may be the order of Earth's magnetism, North and South Pole? What is the strength of Earth's magnetism? Anyone?
10 raised to minus 5, I think.
10 raised to minus 5 what?
Tesla,
ma'am. Tesla, ma'am.
Okay. Usually B, the flux density is mentioned in Tesla, but what happens is that Tesla is a very high quantity. 1 Tesla is a huge quantity. So that is SI unit. Yeah, okay, we'll come to that later on. But so what people do is sometimes they mention it in terms of Gauss. And Earth's magnetism is of the order of half a Gauss. Okay. That is what you said, because 1 Tesla, 1 Gauss is equal to 10 raised to minus 4 Tesla. Very small. So that can be mentioned only in terms of Gauss. And okay, let's start the actual phenomena. And during the journey, I will discuss more. Okay. Okay. So magnetic circuits. Now about the attraction that I have said, don't mention that I have told you. Okay. Okay, there is that recording, but the recording should be very safe with you only. Okay. The closed path over which electricity passes is called as an electrical circuit. Similarly, a closed path followed by magnetic flux is called magnetic circuit. They never say that magnetic flux, this is electric current. Okay. Electric current, because it is a current, it always flows. Magnetic flux doesn't flow, we say it is created or formed, or flux follows a path. These are the terms that we never say that the flux flows. Okay, so the path over which electric current flows is the electric circuit. Similarly, magnetic flux, wherever it follows, it is called as the magnetic circuit. And in a magnetic circuit, as you know, the magnetic flux leaves the North Pole and comes to the South Pole through an external circuit. Or within the magnet, it is from South Pole to North Pole, whatever. We are not going into the actual magnetism here. What we are discussing is the magnetic circuits formed by electrical energy. Okay. So if I consider a toroidal iron ring like this, if I consider toroidal iron ring like this, okay, and I am having a winding like this, okay. And passing current through this, say current I. There are n turns in this ring, as a result of which a flux will be formed here, flux phi, which I usually denote by flux phi, and let the mean length, if the mean length of the flux path is L, then I say that the magnetizing force. I'm not explaining much about this. If you want more explanation, kindly say, because I know that you have learned this. This is called as a toroid, or it is also known as a ring solenoid. Why is it called solenoid? This is an iron, solid iron or any magnetic material. Now, it is not a magnet by its own, but in order to make it magnetic, I just wind some windings of, say, capital N turns, and I pass current through it. When I pass current through it, the flux flows through this path. Flux, we'll see a detailed description later on. Flux flux will be formed. I cannot say flows. Flux will be formed in this path. Now, I'm just writing the formula. All these formulae have been derived actually from the Maxwell's equation. But sadly, this Maxwell equation, etc., you'll be learning only in other higher semesters. Okay. But if you think about the evolution of how these equations came, it came from Maxwell's equation and similar kind of equation, Bessel functions and so on. Let's not discuss about that. So magnetizing force H is given by Ni by L. Ni by L, unit is ampere turns per meter. Naturally, ampere turns per meter. L is in meters. So magnetizing force H is equal to Ni by L. Now, flux density in the toroid. Flux density is usually denoted by B. Flux density, flux, I'll be giving you notes on this, but just take down some points. Flux density within the toroid, B is equal to, what is the relation between B and H? B is equal to mu H, or B is equal to mu 0 mu r into H, where mu 0 and mu r are the permeabilities. Mu is the absolute permeability, mu 0 is the permeability of free space, mu r is the relative permeability. We'll discuss about those also. What does those indicate later on? So you will have mu 0 mu r Ni by L. So much Tesla. And the flux will be flux in the toroid. Phi is equal to B by area. If the area of cross section is capital A, B by area, that will be mu 0 mu r Ni by L into A. Sorry, flux density into A. Flux density B is equal to flux by area. Okay, flux by area. So this is this. Now let's concentrate more on this equation. If I concentrate more on this equation, let me okay. So what I have got is flux phi is equal to mu 0 mu r Ni by L into A. I'm going to rearrange the terms so that I get Ni by L by mu 0 mu r into A, or Ni by S, where S is equal to L by mu 0 mu r into A is called as the reluctance of the magnetic path. Now let us draw a similarity with the electrical circuit. If so, flux phi is equal to Ni by S, and current I is equal to V by R. So if I can draw a similarity between these two, I can say this V we denote by EMF, electromotive force, R is the resistance, I is the current. In similar case, I can say flux, this is reluctance, and this naturally should be your MMF, magnetomotive force. So whatever resistance is doing in an electrical circuit, a similar kind of thing is happening in the magnetic circuit due to reluctance. Reluctance is actually the opposition to creation of magnetic flux. Now, let me ask you why we have provided a toroid a ring. When I spoke about why did we provide a ring and then give? Because flux, the reluctance of this path, reluctance offered by the magnetic material like iron is much less than the reluctance offered by air. So what will happen is that flux will more and more flux will be produced within the toroid. For example, if you're walking along a forest and you have a lot of trees and lot of bushes there, but somehow a path has been, someone has made sure that a path has been cut over through the forest. Then it's normal for anyone to, so suppose we have gone on a tour with say 60 of you are there, and we have been given an adventurous tour. And if if the forest ranger comes and tells us that you can follow this path and come there, what will happen? All of you or most of you will be going along the path that has already been cut, or where all the trees have been cleared and the path is there. But some of you, more adventurous, some of you may go through the forest. Now those flux are called as the leakage flux. Some amount of flux may even leak to the air. That is called leakage flux. Leakage flux. Now this is a major difference between electrical circuit and magnetic circuit. Very important, extremely important, because you have very good insulators for electrical circuits, very good insulator for electric current. That is exactly why you have electric wires connected all over the halls or all over the room where you're sitting, and you are not getting shocked. None of the electric current is passing through you because it's well insulated. But this is not the fact with magnetic circuit. Even air can give or can have some or magnetic circuit or magnetism can be formed or flux can be formed even in air. Why? Because reluctance S is equal to L by mu 0 mu r into A. In the case of air, you don't have mu r. Okay. So mu 0, there is some value of mu 0. What is mu 0? Permeability. What do you mean by permeability? Permeability is actually the reverse of, you can see that reluctance and permeability are inversely proportional. So if there is some value of permeability is actually the conductivity of flux. Permeability is actually the conductivity of flux. If more, you can say the more permeable a material is, more flux can pass through it. Okay, so air is a very bad conductor of flux, yet it is a conductor. It is not a full insulator. That is why we say, even if you have Wi-Fi and all those things, some amount of magnetism, some amount of magnetic flux will be over there, or even in air. It's a very important phenomenon. It's a very important difference. And that is exactly why we are concerned about leakage flux. Though I say that we are concerned about leakage flux, in any rotating machines, like a DC motor or a DC generator or an AC motor or AC generator, where the machine sitting in Idukki generating station, you have a stator. That is, stator means a stationary thing, and you have a rotor also. Rotor is the one which is rotating. So there will be a magnetism, some rotation will be. But in between these two, I have drawn this as a very large quantity, but actually in between these two, you have something known as an air gap. So actually the air gap is of very small order. I have just enhanced the view. Okay, you have a stator and you have a rotor rotating within the stator, whatever be the type of machine. Everywhere you have a rotor and a stator. Now, you need the flux to pass through this air gap. There is some kind of a magnetism and electromagnetic induction, all those things are happening. So in order for that to happen, the flux has to pass through the rotor. It has to form paths through the rotor. How can that happen? Only that can happen only if the air conducts or air has some conductivity or has permeability for magnetic flux. So flux can be produced even in air, but the problem is because air is a bad conductor of magnetic flux. It is not an insulator, but a bad conductor of magnetic flux. The flux has to be pushed through the air gap. Flux has to be pushed through the air gap. So you require a little more. What do you need there? You know, flux is equal to MMF by reluctance. So if we want to, if reluctance is extremely high, so in order to make the flux the same, what should we do? You have to increase the MMF, or you have to, what is MMF? NHI, we have discussed HL, which is the same as NI, is the MMF. Okay, we said that H is equal to Ni by L. So cross multiplying, I'll get this as this. HL is equal to Ni. Or if it is a solenoid that I'm thinking about, if it is an electromagnet which I'm thinking about, I may have to either increase the number of turns, or I may have to increase the current I so as to maintain the flux the same even when the reluctance is very high, or through the air gap I have to push the flux through it, which means I have to increase the MMF. But as electrical engineers, we should be thankful that air is not an insulator of magnetic flux, because only then there is this, only then there can be rotating machinery. Only then there can be rotating machinery, because you have to make the flux pass through the air. Okay. And now let's just concentrate on this equation alone. This equation alone, HL is equal to Ni. You can see that I is an electrical quantity. You can see H is a magnetic quantity. See, that is why I said they are twin brothers, or brothers who have been separated because of a train accident, but coming together when life needed most, or when coming together for the family, because the same equation on one side contains a quantity of magnetism and the other side contains a quantity of electricity. So HL is equal to Ni. Okay, so I think I have reached 11:30. Varsha didn't actually remind me.
I thought 1 minute now, so I thought
Yeah.
need to finish it.
Okay, so I don't know if I have been going through some stories like that, but this is how magnetism is important for electrical engineers like us. So we'll be dealing with this more as classes come by. So that's all for today. Thank you.